Hello everybody, I would like to show you today how to make this animation that I have shared recently on my Instagram, and let's give a look to that. First of all, it's animatable, so we will see how to use the new version of Tissue for Blender 2.80 in order to make animation using the tessellation. And also, as you can see, we have some components that are deformed according to the shape of a surface. So this is something new for this version. It's not possible to do that on the previous version of Tissue. And also, as you can see, we are able to rotate and change the scale of that component in any direction with that level of freedom. So let's start obviously from a default torus that we can use in order to make the general shape, the base object that we want to use in our tessellation. So let's move to layout, and we can keep the cube, but let's add a new object. It is a torus, and this torus can be moved here. For example, I want to make it bigger. So we can scale it like this, and as you can see in the animation, we can actually see better here. The shape of the components is not aligned to the direction of the usual faces of the torus, but are more like diamonds. And in order to generate diamonds in Blender, you can use just the decimate modifier, and using this we can go to decimate and subdivide and remove some subdivision, making this kind of shape. Now I want to obviously make it more rounded, so I must add a subdivision surface, couple of iterations. We can make it more thicker using actually we can also use modifier if you want to make it parametrically, because you can just use displace. And with that displace, you can now change how thick is your object. Okay. Now imagine that you have this component that you want to apply on that object. Let's make it a bit different. For instance, okay, I'll just do something like this, just for understanding better what's happening. If I do a tessellation of this object on this, Tissue is now here. We can do tessellate. If you just press OK, you are using the original faces of this geometry. And if you want to use the modifiers in the object data, you have now all the Tissue tessellate settings. You can use the modifier for the base object, that is the torus, as you can see. So if we choose use modifiers, now you are using all the faces that are generating after the modifier stack. The problem in that case is that we have too many components, because in our animation we have bigger components that follow that shape. But the problem with the default tessellation is that you can make component bigger but reducing the smoothness of the surface. So if I reduce the number of subdivision surfaces and I refresh it, I can do that, but each component is actually a bit square. It's not really smooth and follow the shape. We can see it more clear if we subdivide this object here. Let's add some subdivisions like this. If I refresh, now you see quite better that each component is applied to a flat face, or maximum at a distorted quad, not for sure as a curved shape. And in order to make things follow that shape of the component, basically what I would like to see is to see optimal display. I would like, no, because I can't see the decimate here, but if we use optimal display, if we turn on wireframe, we reduce a little bit, if we increase the number of subdivisions too much, You should get the point. Okay, so now, yes, okay, now you can see with different colors the faces previously generated previously of the subdivision surface. So you can see that we have some big face that at some point become curved according to the subdivision surface. So what I would like to use are those faces and make bigger component, big like those, but with the same curve, with the same smooth curvature. And in order to do that, instead of using the default quad mode for the tessellation, we need to use patch. If you use patch, now you can see that you have smoother component, but with the same size that we can see here. Patch is works fine for this particular situation. Let's remove, for example, some faces. Also those. Works pretty fine, as you can see. We can merge it, smooth it. We can add, I don't know, smooth. And you can make quite organic shapes and keep the curvature of the surfaces, but work with a more detailed component without having this flatness that we have seen before. And in this case, the only problem, the only constraint is that all the faces that are subdivided using the subdivision surface must be quad. So you can have several modifiers in that modifier stack. You can also add textures if you want. For instance, just use clouds texture like this. We can change like this, and you can still refresh it. And you can see that you can make distortion. You can keep all the distortion that you are applying using the modifier stack. The only thing that you can do is to use some modifiers that alter the topology of the mesh after the last subdivision surface that you have here. For instance, you can't use a wireframe here, because this wireframe alters the topology of the mesh, and the patch modifier will use the tiny faces that you have here. I'm not updating that, otherwise it will be super heavy. But let's try to explain better with a more simple geometry. For instance, we have a cube, and we want to do a tessellation using patch on that. Let's use patch directly from here. Okay, great. As you can see, by default, you don't have really the curvature. This is just the interpolation of the normals. But if in this object you had a subdivision surface and you refresh, okay, now you see the curvature. If you have two subdivision surfaces, like one here and another one, and another one here, it will consider for the patch generation, for the patch description, only the last one. So if you refresh it, you will see that the first subdivision surface is increasing the number of components, while the second one is controlling the curvature of the component. So the only subdivision surface that we will use is the last one. If, for example, I use a wireframe after the first subdivision surface and I refresh it, it gives me an error, because okay, I have to handle better the error thing, but gives an error because I'm using a modifier that changes the topology after the subdivision surface. But if I add a second subdivision surface, now if I refresh it, it's super thick, so it's not possible to see really good. the result. You can change the scale to 0.2. Okay, now you can see that it's generating each component inside those faces here, that I can make it more visible using optimal display. Okay, so now you see that you can use actually modifiers that change the topology, but not after the subdivision surface, not after the last subdivision surface. So in this case, everything that is before the last subdivision surface is just describing the new geometry. This subdivision surface is describing the patches. And if you add something else, you can, but must be something that doesn't alter the topology. So for instance, we used before the displays can be one, or also the wave. So you can animate this wave, okay, and you can pick one particular frame, well, okay, like this. If I refresh it, now, as you can see, I can use that modifier because it's not something that is altering the topology. Well, let me see how it looks with smooth. No, we are not merging it. Merge. Nice. Okay, I hope that you get more or less the idea behind the patch modifier. If you do something like a triangular face here, no, this is not a problem actually, but if you use a triangulate before the last subdivision surface, you are working with patches that are triangular, it doesn't work properly. It will give probably some strange error. I have to handle better this error control. Okay, so from here remove that, otherwise it will be a mess. Okay, I don't want to use the displays in this case, or actually I want to use it but without the texture, so I want just to change the thickness of the torus. So if I refresh it now, okay, it's more regular. Okay, in the animation I use actually a much more simpler component, and let's create something simpler like just a cube. I created that cube with some holes on two different sides, faces. Okay, now if I delete that and I do a new tessellation, tessellate, patch, okay, okay, you see flat components. Why? Because the resolution of that component is really low. If here I add a subdivision surface, maybe, okay, keep in that way, I can increase the number of subdivisions. If I refresh, actually I must change some settings because I must use the modifiers of my components. Now you can see that is rounded, because the quality, the resolution of this final geometry depends on the resolution of that, and the interpolation quality depends on the number of subdivisions that you have here. So if I have few subdivisions, just one subdivision here, if I refresh it, you can see that is a bit, you can see some corners, because the interpolation quality depends on this number of subdivisions, because it's linearly interpolated between each face. If I increase even more, should be even more visible, this effect. Yes. So it's better to balance correctly the resolution of a component and the interpolation quality of the surface that you're using. Don't use super heavy subdivisions if you don't really need them, otherwise it will make the tessellation slower. Refresh. Okay, for instance, this can be good, because after that you can add a subdivision surface and fix all of them. Okay, now we have this problem here, because apparently the direction of the The orientation of a face is not the orientation. The order of the vertices of a faces generated by the decimate is not really super correct. So we probably need to fix it manually. We can apply it, and we can, for instance, select the faces that have some problems, and we can fix them just selecting them and pressing rotate faces. And as you can see, you can fix them. Rotate faces, and they are following apparently that direction. Rotate faces. Nope. This one. Rotate faces. And you can fix it manually in that way, or if you want, probably is the most correct way, you can use the UV editing. So basically you can use the UV orientation in order to keep all of them consistent. So usually in this case I just select one face, I press U and I reset the UV map for that face. Then selecting everything, I press U again and I use follow active quad. Okay, now you can see it's unfolding in this more regular way, and all the faces are unfolded according to the orientation of this first one. Now if I use now we still have some problem. You should see this fixed. If I change the tissue tessellate and I choose rotation active UV, well, now it is fixed, and I'm sure that the rotation is the same for all of them. Okay, now the other thing that we need to do, let's return to layout, is to take care of alignment, because for instance if I want to make this element thinner, I can't, because by default I'm using an option that is called bounds. This will check automatically the size of this component and will make it fitting perfectly the faces, or in this case the patches of my base object. But in this case I want the freedom to make things smaller than the face. So in this case I must use local or global. I prefer use global because allows me to also play with the rotation with more freedom. So we can do something similar to what we have seen here. As you can see, this component is not only smaller than the patches that we are using, but is also rotating as it's changing its coordinate system. So it's more easy to do this kind of effect if we work with global. In this case, in order to use global, you have to make sure that your component is fitting the correct portion of the grid. That is this one. It's a portion of space that goes from 0, 0, 0 to 1, 1, 0. And the position according to the offset position according to the surface of the base depends on the z coordinate. So in this case, because my object is in between of the grid, is aligned in this way to the grid, my tessellation will be generated according to the midpoint of the surface, half inside and half outside. So if I change global, okay, you see very small change, but you see already that we have some small gaps here. And if I scale it according like this, okay, 0.5, if I refresh it, you see that now we can make it smaller compared to the patches. Okay. So in order to do the animation that you have seen, we need to modify a little bit this guy. So actually I just added some loops here, as x 0.5, some loops here, as z 0.5, some loops here, no, oops, sx 0.5, and some loops here, sz 0.5. Okay, I deleted those faces. Okay, and instead of using the Catmull Clark, I use just the simple. So now if I refresh it, okay, you see that. Now we can add the thickness and other smoothness just directly from here. So we can add some modifiers like a solidify and another one as a subdivision surface. And now let's remove a wireframe. And now if I change something, for instance, if I make it a bit thicker, like this, and I refresh it, you see that keeps all the modifiers that we have. Want to make probably more thicker, too much. If you want to set it smooth, if you do it manually after, and if you refresh the tessellation, you will lose the smoothness, but in the tessellation settings you can activate smooth shading. Okay. We can also use merge, that will connect automatically all those parts. Okay, now as you can see we have Animatable option here, that if you turn it on, each time that you change the current frame, it will compute again the tessellation. So each time that I change the frame, I'm using the keyboard, you can see that it will take a little bit for computing again. It's not super fast, because each time that I change the frame is running again the tessellation. But if I animate this guy somehow, for instance, if I set this rotation here, lock rod scale, I'm pressing I for adding a frame here. Okay, I can move to the frame 50, and I can change the rotation Rx of 90, I, lock rod scale. Okay. If I run my animation now, you see that this guy here is slowing, rotating, according to the rotation of a component. Let me go closer. So in this case you can change the size, the rotation, the alignment of that component, and you will get this animatable result in the viewport. If you want to make it faster, probably it's better to deactivate the subdivision surface, that in this version of Blender 2.80 is quite slow. Yes, much better. And also, because we are working with a global coordinate, let's move to 50, we can also change the position, and this will affect how this component is applied to my geometry. For instance, if we go to the frame 100 and we rotate in that direction, maybe we can scale also according to that axis of 0.3, making it thinner. We can add lock rod scale here, and to the frame 150 we can, for instance, move in that direction, like this, high lock rod scale. Now if I go here and if I run my animation, you see that now we are moving away, and we continue moving according to the last direction that the patch gave to them. So we are moving away. You can make them return back to home. And that's it. It's not exactly the animation that I've done, but I mean, you get the point. You can change it the way that you prefer. You can make different rotation. You can move in different way your component. But the thing is that now working with a global coordinate, you have the freedom of change manually all those rotation and alignment. And also using patch, you have the freedom to make a bigger component that are more independent to the topology of object. So, for instance, yeah, I mean, you get the point. Thanks for watching.